Chapter 4, Digital Modulation, Lesson number 2. Digital modulation or coded modulation is a modulation technique where the digital information signal is conveyed over an analog carrier signal. There are many types of digital modulation techniques. In this lesson, we will cover amplitude shift keying, frequency shift keying, phase shift keying, binary phase shift keying, quaternary phase shift keying, and quadrature amplitude modulation technique. ASK is a modulation technique where the digital information signal is directly modulates the amplitude of the analog carrier. Based on the given mathematical equation of ASK waveform, Vm of t represents the information signal and Vc represents the amplitude of the analog carrier. When Vm of t equal to 1 volt or in binary form as a logic 1, the final equation of ASK waveform becomes Vc cos omega ct. This equation represents the analog carrier. When Vm of t equal to negative 1 volt or logic 0, the final equation of ASK waveform becomes 0. Based on this ASK waveform, notice that the carrier signal will be generated at the output when the input signal has logic 1. ASK also known as on-off keying because the carrier wave is switched on and off by the input data. However, it is no longer used in digital communication system due to noise problem. Frequency shift keying is a modulation technique where the frequency of the carrier varies with the binary level of the information signal. Based on the given FSK mathematical waveform, when input Vm of t equal to positive 1 volt or logic 1, the frequency of the FSK waveform will be shifted above the carrier frequency with the amount of delta f. When the input Vm of t equal to negative 1 volt or logic 0, the FSK frequency will be shifted below the carrier frequency by delta f. From the general mathematical equation of FSK waveform, the shifting in the carrier frequency is directly proportional to the amplitude of the information signal. Notice that the digital modulating signal has a normalized binary waveform. That means logic 1 is represented by positive 1 volt and logic 0 can be represented by negative 1 volt. FSK technique is mainly used for low-speed transmission data. FSK signal can be represented in frequency domain as in this figure. The amount of shifting in carrier frequency can be calculated by taking the absolute difference between the mark and space frequencies and divide by 2. FSK waveform in time domain can be shown as in this figure. Based on the output signal, we can see that the carrier signal has low frequency for logic 0 and high frequency for logic 1. Phase shift keying is a modulation technique where the phase of the carrier signal is shifted by a certain amount of angle when the pulse of the information signal is changed from logic 1 to logic 0 or from logic 0 to logic 1. Based on the modulated result, we can see that the phase of the carrier signal is shifted by 180 degrees. This figure shows the PSK waveform in time domain. When the digital input data change from 1 to 0 or from 0 to 1, the phase of the carrier signal will be shifted by 180 degrees. This figure illustrates the comparison between ASK, FSK and PSK waveforms. By using ASK technique, when the information signal has logic 0, the carrier signal will be suppressed. In FSK technique, the frequency of the carrier will higher for logic 1 and lower for logic 0. Based on this PSK waveform, the phase of the carrier is shifted by 180 degrees when the binary level of the modulating signal is changed from 1 to 0 or from 0 to 1. M-array modulation technique is a type of digital modulation where instead of transmitting one bit at a time, two or more bits are transmitted simultaneously. This type of transmission will reduce a channel bandwidth. M-array is a term derived from the word M-binary, where M represents a digit, which is correspond to the number of conditions, levels, or combinations which is possible for a given number of variables. The number of bits necessary to produce a given number of conditions is equal to log 2m. If we rearrange this mathematical equation, number of conditions m is equal to 2 power n. Binary phase shift keying is a modulation technique which encodes the digital information signal onto the carrier signal with single bits per sample. When n equal to 1, number of possible output phase is equal to 2. When information signal has logic 0, carrier signal will start to oscillate at the angle 180 degrees. For logic 1, carrier signal will oscillate at 0 degrees. Based on this BPSK waveform, notice that when the input digital information change from 1 to 0, the phase of the modulated carrier signal will start to oscillate at the phase angle of 180 degrees. When the input of digital information signal change from 0 to 1, the modulated carrier signal starts to oscillate at the phase angle of 0 degrees. This BPSK phasor diagram shows an arrow pointing to 0 degrees for logic 1 and another arrow pointing to 180 degrees for logic 0. In BPSK constellation diagram, both oscillation angles are represented by constellation point. Quaternary phase shift keying is a modulation technique which encode the digital information signal onto the carrier signal with 2 bits per sample. With n equal to 2, there are 4 possible input conditions and 4 possible output phases. The 4 possible output phases are 45 degree, 135 degree, 225 degree, and 315 degree. Based on the given QPSK mathematical equation, we can see that when the input signal is 1, 1, the amount of phase shift in carrier frequency is 45 degree. For input signal 1, 0 and 0, 0, the amount of shifting in carrier phase is 135 and 225 degree. For input 0, 1, the amount of shifting in carrier phase is 315 degree. QPSK waveform at different phases in time domain can be shown as in figure below. Based on the truth table, when the input binary signal is 1, 1, the phase of the carrier signal will be shifted by 45 degrees. Therefore, carrier signal will start to oscillate at a point shown in reference waveform. Then carrier signal will make one complete cycle. This QPSK phasor diagram shows 4 arrows pointing to 4 different output phases. Notice that all the binary input signals have the same amplitude. The same goes to QPSK constellation diagram, where all the binary input signals have the same amplitude. 8 phase shift keying encode the digital information signal with 3 bits per sample. When n equal to 3, number of possible output phases are equal to 8. This 8 PSK constellation diagram shows the 8 possible input conditions together with their output phase. For quadrature amplitude modulation, the digital input information is contained in amplitude and the phase of the transmitted carrier. This figure shows a constellation diagram for 8 QAM. Notice that each output phase represents 2 different binary input signals. However, these 2 input signals have different amplitudes. 16 PSK encodes the digital information signal with 4 bits per sample. Therefore, with this technique, there are 16 possible input signals and 16 possible output phases. Based on this 16 PSK truth table, we can see that with input signal 0001, the modulated output phase is 33.75 degrees. Based on this 16 QAM constellation diagram, notice that some of the output phase represents 2 binary input signals with different amplitude, and some of the output phases represent 1 binary input signal. Modem is an important device used in data communication system. Modems come from the word modulator and demodulator. Since information cannot be transported directly over the analog transmission medium, thus we need a modem as an interface. Actually, modem is a repeater that converts electrical signal in digital form into analog form, or electrical signal in analog form into digital form. Modem only retransmit data and does not interpret or change the information contained in the data. At the transmitter, modem works as a modulator. Modem will encode the digital information signal onto an analog carrier signal before transported it through an analog communication medium. Therefore, the output of a modem is an analog signal that is carrying digital information. At the receiver side, modem works as a demodulator. It will extract digital information from digitally modulated analog carriers. Based on this analog transmission channel, we can see that modem will convert the digital information signal into analog signal through the modulation process. The digitally modulated analog signal will be received at the modem in the receiver side. Here, modem will convert the transmitted analog signal to the digital signal. Multiplexing is a process of transmitting an information signal using a device called multiplexer. A multiplexer can transmit one or more information signal to one or more destination over the same transmission medium. This example shows how to calculate the transmission bit rate for human voice when the minimum sampling rate is used. At the end of this lesson, please ensure that all of you can grab all these outcomes. Thank you.